Okay, so now you've taken your pre-assessment. We're going to go through this slideshow. It'll get us started a little bit, okay? So welcome to Bootstrap, right? You're now going to be learning a new programming language. And you're actually going to learn two in this class, right? We're going to start with this first one. Now, programming language is a way to tell computers exactly what you want them to do, right? Computers are actually pretty dumb. They only do exactly what you tell them to do, and you have to speak their language in order to tell them to do it. So it says just like English, Spanish, or French, a programming language has its own vocabulary and grammar that you'll have to learn. Fortunately, the language you'll be using here has a lot in common with simple math that you already know. So let's begin by exploring a simple video game and then figuring out how this works. So let's open this link. Now this link is going to be, right now I'm going to actually even right now, going to put this into, into a link for us. So I'll paste that there. This is going to go into our links, is the name of the topic. And this one is to play Ninja Cat. We're going to play a game called Ninja Cat, okay? And let's see, I'm going to have this one go then. Okay, so you'll have that link, and when you click on it, it's going to open up this game, okay? It's called Ninja Cat. You click Run, and you can click Run full screen. I'm not going to do that. But you can go ahead and try to see if you can get a high score on this. Take a few minutes to play the game. Follow the instructions. I want you to just check it out, okay? In fact, you can just pause this video, please, at this moment, and then return after everybody's had a little bit of time to play the game. Probably a good 5 minutes or so to find it, play it, you know, whatever. Okay, so now everybody has played the game. Let's talk about the game, right? You move around, right, with the left and the right, and you're gonna be making a game that's very similar to this, maybe a little bit better or more interesting, but similar, okay? And so we're gonna start by analyzing the game a little bit, right? You have some certain characters in this game, right? The Ruby moves from the right to the left. So does the dog. They're coming across the screen to the right and left. The Ninja Cat only moves when you hit the arrow keys, and she can only move left, right, up, or down. Okay? You figure out how the game works by first understanding how each character works. So there are absolute rules that guide how the characters behave. And, of course, we're going to have to make sure we're very clear on those rules so that we can give them as instructions in our video game program. Okay? Okay. So now in your workbook, if you go to page 2, you're going to have this table here, and you're going to go ahead and start filling it in. Let's take a minute. Let's see, page 2, make this a little bit bigger here. You should be filling this in. So writing down what are some of the things you see in the game, what is changing about it, and then get very specific. How is it changing? So here the first one's done for you, right? It says the thing in the game is cloud. What's changing about it is its position, and then more specifically, the x-coordinate is changing. So in other words, when the cloud went across the screen, it wasn't going up and down, it was going to the right or to the left, I can't remember, but it was just moving left or right, which means that its x-coordinate, if we think about things on the screen having a value on a number line, and you think about the x number line that you learned about in pre-algebra and algebra, that it was the axis that moved across. Here's the x-axis, right? And they all have numbers, so when things are moving left and right, really what we're doing is we're changing their x-coordinate. Okay, so now we want you to let's see if I can get, oh, this is not liking me right now. Okay, what we want to do is we want to go ahead and see if you can fill in the rest of these things. What else did you notice that changed? And see if you can notice everything that changes. So again, let me go back here and pull up the game one more time. And I want you to notice everything about this game that is in there. Obviously, we have everything that's changed. There's something that changed, right? And you have all this stuff that's changing. But even on the top, look over at the top to the right, right? What else can you see that's changing, okay? So see if you can figure that out. I know you're looking at me going, Mr. T, you suck, and that's fine. But anyway, fill in that table. So we pause the video here and give you guys time to fill it out. Okay, so hopefully, now you've got it all filled in with some of your ideas. Did you get all 4 of the moving characters? Right? The cloud was 1, right? So there were 3 others. What others were there? Should have had the player, which is the ninja cat, right? The target, which was the ruby, and of course the danger, which is the dog, right? All right. Did you see anything else? You have the background is a part of the game, but it's not changing. And the score, hopefully you notice the score changes, right? All right. So, there you go. You can list everything that's in the game and whether or not it changes. A lot of the stuff like the background is not changing, right? But you should go ahead and fill in everything here now about what's changing, okay? And if it doesn't change at all, you can write that down too, right? And just leave the part that changes blank, right? And the part of the table that is blank, right? All right, so now here we're just talking about the number line again, right? It says computers use numbers to represent a character's position on screen. So using number lines as rulers to measure the distance from the bottom left corner of the screen, for our video game, we will place the number line so that the screen runs from 0 down here in the corner is 0. It's going to go across the screen to over here where it's 640. So we'll have 0 to 640, and then it's going to go 0 to 480 from the bottom to the top. So it'll be 640 by 480. So does anybody know what units we're counting? 640 what? Okay, maybe by now you figured out that it's 640 pixels, right? So you're saying what pixels, exactly a location, which pixel is the location of the character, okay? We take the image of the dog, stick it anywhere on the line, measure the distance back to the left-hand edge. Anyone else who knows about our number line will be able to duplicate the exact position of the dog, knowing only the number. So if you had the dog, right, and you set the dog, let's say it was set right here, well, remember the distance is from the left corner, so we'd go 0 out here, 100 out here, 200 out here, 320, 400, maybe that's around 500 or 520, somewhere around here, right? So you can see that if we gave that number 520, then anybody that has the same, understands what we're looking at is going to be able to put the dog right where it is, and that includes the computer. The computer knows, oh, you want 520 pixels, then let me start over here, go over 520 pixels, and then this is where I'll put your dog, right? All right. So, if you think about it, what happens if you're all the way over here? What number would you use? Should be 640. What if you're right in the center? Exactly. It should be half of 640, right? 320. And then, what about on the left over here? That would be what? Should be 0. Okay. When you add in the second number, right, which is the y-axis over here, now you can locate the character anywhere in either dimension, to the right, to the left, up, and down, right? So we're going to start down here just like we did in algebra, pre-algebra. We start at 0, 0. Go to the right, we increase the x-axis, the x value. Go up, you increase the y value from 0. Remember, the first number is to go with the first number line that you learned. In alphabetical order, it's x. This is the one that comes first, is the x-axis, right? And it is the first number. The second number is for the second number line you learned, or second dimension that we learned to count in, which would be the y-axis. So you get your coordinates from x and y, the first number telling us left or right, the second number telling us up or down. And what's going to be displayed on our screen is just going to fit 0 to 640, and from 0 to 480. So clearly, if there was anything in these areas over here, these areas over here are going to be negatives, right? So they would not show up on our screen. Okay? So it says we can locate a character anywhere on the screen in either dimension, right? As long as we don't go above 480 or beyond 640 on the x-axis or above 480 on the y-axis, we'd be able to see it, right? It says the second line runs up. It's called the y-axis. So the two-dimensional coordinate consists of the x and the y locations on the axis. And so for our game, we've got to get pretty good at this, understanding, oh yeah, I want my character to be at this position or that position. We look at the how far over from the left it is, right, in the x-axis, and how far up from the x-axis it is to get to the position of the cat, right? Okay. Let's keep going. Now, suppose we want to locate Ninja Cat's position on the screen. We find the x coordinate by dropping the line down from Ninja Cat. Read the position on the number line. The y coordinate is done by doing the same, right? Running a line to the y-axis. So just, you can kind of see, here we have it right here. There's the cat, and you can see the line coming down here to check what number it's at, and a line coming across, check what number it's at. Check this one first. This is the x-axis, and then that'd be the first number recorded, and then check this one second for the y-axis, right? Okay? We write them down in that order, right? So when you see 250, that means the x-coordinate is 200 and the y-coordinate is 50. Okay? Now, thinking about how the character moves, right, we are changing some of the values. If we are moving to the right, right, or to the left, we're going to be changing the x value. If we were moving up or down, we would be changing the y value. And, you know, if you wanted to move diagonally, you'd have to change both the x and the y at the same time, right? All right, now think about when Ninja Cat moves up and down in the game, right? And, oh, it says, can Ninja Cat move up and down in the game? The answer is yes. She jumps, right? And can she move left and right? Yes. So what changes about her is her x-coordinate and her y-coordinate, or sometimes both, right? Can change both of those things. The clouds, what did the clouds do? Clouds went across the screen, right? So they only change their x-axis, their x-coordinate. And how is the x-coordinate changing? So if it started over here and we said this part of the screen over here, on the right, this is 640. So here it is. This should be at 640. As it moves this direction, the cloud, as it goes across the screen this direction, we are actually just lowering that number. From 640, it's going down. So we just subtract from 640, right? So we're always taking that y-coordinate. We're just telling the computer, hey, when you update, take away a couple of pixels, and that'll keep it moving, right? Take away a couple pixels from the x value, and that'll keep it moving. Okay? So now think about what's going to be changing the x and the y for the dog, the Ruby, for Ninja Cat, right? Make sure that's all filled in. Now take a minute and you're going to go to page 3 in your workbook. And in here, I want you to just do an estimate. Now this, sometimes kids get all tied up about whether or not they got it exactly right. These are estimates, right? So what we want you to do is we want you just to make sure you get an idea for where things are. So take a minute, think about what number this would be halfway, and then what number this would be, and then what number this would be, etc. And where would you be placing our Ninja Cat? Where would you be placing the dog? Where would you be placing the cloud and the Ruby? Answer these questions down here. What would the x and the y coordinates? I want everybody to do this on their own. And pause the video so we can get it done. And then if the teacher would, when everybody seems to be done, compare the numbers to see if they have similar numbers to what we have here. So go ahead and pause the video now. Okay, so hopefully you got it figured out. Let me just tell you what I have as I look at this. I think halfway is 320. And then halfway again is about 160, and I think this is a little less, so I'd probably say this is about 150. Now the interesting thing is it depends on, you know, what part of the cat you're looking at, right? Because this is a lot of pixels in here. So, you know, I would say we're going to go right by the center of the cat, right? So this is somewhere around 145, 150. And then if I think about how tall this screen is, 480 characters tall. So halfway right here would be 240. half again would be 120, and that's pretty good. I'd say it's probably more like 140 or 145 and 100 maybe, or even 90, something like that. Okay, so again, it's not important that you get the exact numbers I got. It's important that you get some realistic numbers. Okay, so hopefully you've been able to do that. Okay, so now this is where you're going to do a little planning for yourself. Okay, we make a list. It's time for you to start working on your own game. And what we want you to do is think about writing out your name in here. What is the name of the game going to be? Where is it going to take place? What are you going to use for the player? Okay, and for the beginning right now, really simple, your first game, that player's just going up and down. Then how are you going to make the target move? And again, in the beginning, the target's only going left and right. And then how do you make the danger move? And again, the danger only goes left and right. Okay? And, you know, you decide what it's going to be. So just before you can plan anything else about your video game, you just got to think about, you know, what you want your game to be. So you should probably take a good 10 minutes here, or 5 to 10 minutes here, and make a plan for what you want your game to be, and share with your neighbors when you're done. Now, it's not a good idea just to copy everybody else's ideas, so I think it's best that you figure out for yourself what you want your game to be, and then you can check with your neighbors to see if they want to have the same exact thing or not, okay? So go ahead and pause the video and get that done. Okay, so hopefully you've got that all planned out. Okay, so now you have to think about the things in your game, right? You've got a background, right? Such a forest, a city space. Where are you going to have your background be? We've got your player, right? It's going to move and respond whenever the user hits a key, like up or down or whatever. You got a target. Target is the thing that we're trying to get, like the prize, the ruby or whatever. You've got this danger. The danger is the thing that comes in from the right or the left. It's something basically we're trying to avoid. We don't want to get hit by the danger. That'll hurt us. Okay? So you filled out page 4 already. And now we're going to start thinking about the language that we're going to write in. All right, so it says math is a language, just like English, Spanish, or any other language. All right, we use nouns like bread, tomato, mustard, and cheese to describe physical objects. So math has values like the numbers 1, 2, or 3 to describe quantities, right? So, you know, if we said something like bread, right, this would be something we're describing, right? The bread tells us what the meaning of the thing is that we're talking about. And math doesn't use values or nouns. It uses values. It gives us a quantity, a number describes a quantity. Okay? All right, and then when we are using language like English, we use verbs. Those are the action words, right? So it says throw, run, build, and jump. I'm going to just say like eat, right? Because we just talked about bread, and I'm getting kind of hungry. So eat bread would tell me that I'm going to take an action. The verb is eat, tells me what I'm going to do, and bread is what I'm going to do it to. That's what I'm going to eat, right? So in math, we have things that are called functions. Functions do things, right, to the quantities, right? Just like we say we eat bread, or here it says you slice bread, right? You can slice bread. So slicing is the action, right? And bread is the noun, the verb and the noun, right? So a person then adds 4 and 5. So adding is our function here. It's like our verb. It tells us what to do. And then we have a couple of numbers, right? 4 and 5. Those are the quantities. Those are the numbers. That's what we're going to add together, right? That's what we're going to do the thing to. Or those are the. So thinking like in English, this would be the verb and these would be the nouns, right? That's basically what we're trying to get across. So in math, we use functions, right? And you've probably never thought about the word add as a function, but basically that's what it is. It does something. You provide a couple of inputs, and then it performs an operation, right? Which we usually addition, we do think about it as an operation, right? So it performs this operation. And what is the operation? Well, it combines things, right? It combines the 4 and the 5 together, and then you recount, and you get the 9. And addition just lets us so we don't have to count it. We just add, okay? So we have a lot of functions in math, right? I mean, we have formal function notation that we use in algebra, but functions are, you know, basically anything that we're performing upon numbers, right? So when we put things together, we make expressions, and that's what this is saying here. A mathematical expression is like a sentence, right? It's an instruction for doing something. The expression 4 plus 5 tells us to add 4 and 5 together, right? To evaluate an expression, we follow the instructions in the expression. So the expression 4 plus 5 evaluates to 9. So in other words, evaluating now, here we have, first of all, we're stringing everything together. The expression tells us to do something, right? It's an instruction to do something. So 4 plus 5, that's the instruction. But until we evaluate it, we don't actually do it, right? So 4 plus 5, we know what that is. But after we do the operation of adding 4 and 5 together, we find the number 9. That's when we have evaluated it. So the same thing is true with computer programming, right? We're basically going to provide some function. We're going to say, you know, like maybe move my character, right? So move would be the operation, the function that we're telling it to do, the verb, and my character is the noun. That's what we want to do it. But until we hit run, right, and start that program up, it is just an expression. It is not actually doing anything. So in math, we say we evaluate it, okay? We evaluate the expression, and then that tells us the value of it. And that's what evaluate comes from, right? This word value in here, right? Values, there is the root of it, right? To find the value of. All right, so what does 8 times 4 evaluate to? All right, what does 20 minus 16 evaluate to? And what about 16 minus 20? Okay, so sometimes this is a kind of a big deal here. Sometimes you got to have more than just a simple expression to accomplish a task. You might need multiple expressions to accomplish a task. Right? So if you're going to write instructions for making a sandwich, it would matter very much which came first. You're going to melt the cheese, slice the bread, spread the mustard, etc. The order of functions matters in math too. If someone says 4 plus 2 minus 1, they could mean several things. First, add the 4 and 2 together, then subtract 1. That looks like this, 4 plus 2 in parentheses, then minus 1. Or they could mean add 4 to whatever the result of subtracting 1 from 2 is. So here we have 4 plus, but in parentheses, 2 minus 1. So now in the parentheses is what makes us wait. The parentheses makes us wait. So we're not going to add until first we figure out, oh, we don't know what to add it to. What do we add 4 to? Well, whatever this is. So first we have to evaluate this, right? Can't add 4 to something is not a number. We've got to get a number. And this expression will evaluate to a number. So once we do 2 minus 1, aha, now we can add 4 plus 1 and we'll get to 5, right? So the parentheses, that's why it always takes, you know, it's always got to be done first. It's the top priority. We do whatever's in parentheses first because we cannot evaluate with a plus sign. We can't evaluate until we're done here. Does that make sense? All right. Now remember, you know, depending on which way you read the expression, you could have very different results. This is a problem because we often use math to share calculations. And for example, you and your cell phone company should agree up front on how much you will pay for sending texts and making calls. And if you and your company look at things differently, you'll obviously get a bill that's off. So it's important that everybody that uses math and tries to communicate using math has to have the same method for communicating about math. Okay, so how do we avoid problems? We make sure we agree on the order, right? So first of all, we all agree on the order, and then we add detail to the expressions that indicate the order, right? Okay. Now we look over here. You've seen this before, this little pyramid, right? And we have this pyramid represents the order of operations, and you're going to think about the levels, right? So down here on the bottom, you have plus and minus, okay? Plus and minus are done last, okay? And we have multiply and divide. There, any multiply or divide is more important. It's higher up and it's more important. It gets done before you add or minus, right? Then above that you would have any exponents, right? Whether you're taking you're squaring something or cubing something, right? Or taking a cube root of something, right? That would all get done before. And then on the very top is anything put into parentheses, right? Anything put in parentheses, well, or any of the, we call them grouping symbols. So you have parentheses and brackets and what we call those braces, curly braces. Those get done first. So the very, very top thing allows us to use the braces, the brackets, the parentheses to create a new order and say this should be done before anything else, right? Then if there's any squaring, we can do that. Then if there's any multiply or divide, we can do that. Then if there's any plus or minus, we do that. Now sometimes people remember, you know, please excuse my dear Aunt Sally, right? And they say, okay, so we got to do the parentheses and then exponent, then multiply, then divide. Well, that's not really true. Multiply and divide, as you can see in the pyramid here, they're on the same exact level. So multiply and divide, you don't do multiplication always before division. You do whatever you see first as you go from left to right, just like we read from left to right. And if you see a division before you see a multiplication, you're supposed to divide first, right? Then you can multiply. Same thing with addition and subtraction. They're exactly equal in power. So we would do either subtraction or addition just going left to right, okay? So it says if both operations are present, as in 4 plus 2 minus 1, we read the expression from left to right and apply the operation in the order in which they appear. So this one tells me to first take 4 plus 2, that'd be 6, then minus 1 gives me 5, right? Okay. And here, you know, they're just in this little paragraph, if you haven't had a chance to kind of read it yet, but it's basically saying do everything at the level before you go down to the next level. All right, so the order that we need to go in here, take a moment, pause the video, and see if you can figure out what order you need to go in. Okay, so hopefully you all agreed, maybe you discussed it, but we would be doing multiply and divide before add and subtract. So here's our multiply and divide. And you can see the divide happens first. So we should go divide, then multiply. So divide, then multiply. So it's got to be either 2 or 3, right? Then we have subtract and add. Those two are even, right? So we're going to do the one on the left first. So subtract and then add. So it's divide, multiply, subtract, and add. Hopefully you got that right. All right, now, this is really cool, but it says one way to indicate the order of operations and expressions is what we call a circle of evaluation. We make a diagram of it, and that helps us. Now, these circles of evaluation, they're going to help so much for us writing code. They're a big deal. It helps us really think through what we need to do, or what the instructions ought to be, because we put it in a circle. So here it says, here you can see an example of a circle evaluation from the math expression 4 minus 5. I'm going to see if I can, let's see if I can draw here on the screen real quick. I don't know if this is going to work or not. Let's say, so I want to do the minus sign. So I'm going to make a circle, and then I'm going to put a minus sign on top, and then I put 4 on the left and 5 on the right. So hopefully you've been able to see that. Yeah, it looks like you can see that there. So that's good. So 4 minus 5 is one way for me to be able to do this. Okay, 4 minus 5. And notice that my minus sign, that's my function. That's the name of the operation that I'm going to be doing. It's the function. It goes on top in my circle of evaluation. And then these numbers 4 and 5, these are the two numbers that I'm going to be subtracting. And the 4 has to go, the first number goes on the left-hand side, and the second number goes on the right-hand side. Okay? So I wonder if I could do it this way. Let's see if this would work too. I don't know. Let's try a circle. Oh yeah, that's not bad. And a line, right? So we put a minus sign, and then we do 4 and 5. And that means 4 minus 5. Okay? All right. Here we're going to move on from that. So now it says there are two rules that we always follow. So the first rule, it says every circle can have only one function. Can't have multiple functions, right? And that function goes on the top of the circle. And then the second rule is that the numbers are written in below the top of the circle, and they go from left to right. So in this case, we have a circle evaluation. It's breaking a rule. We have numbers that are left and right, but that plus sign, where should that go? Okay, so if I were making a circle of evaluation for this, I would put the plus sign on top, right, and then the 6 over here and the 7 over there. Okay, that's how we're going to write it out. That's just, it's going to help us when we have to think through problems that we can design them using this circle of evaluation. Okay, so we are adding 6 and 7, and the plus sign goes here, right? Okay. Let's see, did we get that taken off? I think so. Oh, okay. And my computer just holding up for a second. Let me go back here. All right, so they want us to go ahead and pause the video for a second and see if you can do the circle of evaluation for each one of these, okay? So you pause the video and then check with each other. Maybe have somebody go up to the front of the room and try to get one of these done for each one. Okay, so now I'm going to show you what I get when I do it, and hopefully you got the same thing. So here we go. 6 times 4. Well, I know that that is multiply, so I'm going to put this asterisk. Asterisk is what we use for multiply over here, right? And the two numbers I'm going to multiply are 6 and 4, right? This one is 7 minus 10. So I'm going to make a circle for that. I'm going to put the minus sign in front. Oh, that didn't look like a minus. There it is. 7 minus 10. Okay. We have another one over here for 5 plus 8. So the operation is plus 5 over here, 8 over there. Okay. And then the last one is divide. So we have 351 over here. And we have -1 over there. So 351 is being divided by -1. Did you get all those right? Okay, I hope so. All right. Now, what about when we have multiple functions inside of one another? So here we have 351 divided by, we want -1, but maybe the way we're going to get to -1 is we're going to do 4 minus 5. So let me make this bigger and make sure you can see exactly what it is they've done. All right, so we put a big circle in here. We want to divide, so I'm going to put the divide sign, which is that slash, right? So we're dividing 351, but what are we dividing it by? -1. Perhaps we're not going to make it -1. We're going to get to -1 by writing an expression that evaluates to -1. 4 minus, so if I evaluated this 4 minus 5, I'd get -1, and now I have 351 divided by -1. Now notice that I cannot do this bigger function, the outer function, because I don't know what to divide 351 by until after I do my smaller function on the inside. So when we're looking at our diagrams, we have to know the littlest functions on the inside have to be done first, and the last functions are the ones on the outside. Okay, this is important when we give instructions. The reason we're doing this is because we're going to be giving instructions to the computer. Hey, we want you to do this, 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 and this. And sometimes it's a lot of things that have to happen all at the same time. But the order that they have to happen in might be really important, right? So this is going to help us by sketching it out. We're going to be able to diagram. We're going to make really, really good choices about what we want to, what we're going to need to do. So that's basically what this is for, okay? All right. So it says they want us to finish this. We have a times, we have a circle with a plus, and 23, and another circle with nothing in it. So pause the video here, see if you can get this one finished. Okay. Okay. There's times, all right, on the left. I know I have plus sign, I have 23. So what are we adding to 23? Well, if I look up here, I want to add 7 to 23. So 7 gets added to 23. That'll be what's in this parentheses here. Hey, guess what? This looks like parentheses a little bit, right? It's rounded, all right? Just like that's like almost like a circle, right? So 23 plus 7 goes here. And then we're going to be multiplying that by, but we need another circle, all right? So we'll make another circle. Over here is subtraction, 13 and 5. So we are going to multiply whatever we get when we add 23 and 7 together. What's that going to be? If I evaluate that, I'm going to get 30 when I add those guys together, right? And then 13 take away 5, when I figure out what that is, 13 take away 5 is going to be 8. And then this was multiply, right? So 30 times 8, so the whole thing's going to evaluate to 240. They all have the same meaning, right? This, and this have the same meaning, only this is just the original expression. This is partially evaluated, and this is fully evaluated, right? Okay. All right, here's another one, little circle that they want us to evaluate. I'm going to go ahead and try to make it big enough that you can see it. So we have a, let's see, we have a big circle. It has a plus on top. Oh, that's not real easy to see, but hopefully you can tell what I'm doing. Let me change the size of this so you can make it bigger. All right, so we have a big plus sign. We have a big, huge circle, right? And that we're adding. And on the left, we're adding 6. And what are we adding 6 to? Well, over here on the right, oh, that is not a plus. That's a multiply. Then on the right, we have a smaller circle, and that is plus. And the two things we're adding is 4 and 5. So how would we evaluate this one? Let's just make sure we're clear on this. Before I can do the I can't do the multiplication yet, right? I got to do the addition first. So 4 plus 5 is 9, then 6 times 9 is 54. So you can see that's what it tells us here. It evaluates to 54. So now what we want to get good at is we want to be able to evaluate also, go from, if somebody gave us a diagram, could we write it out in math? So this one here, it looks like 4 plus 5 in a small circle, and then minus 10 in a big circle. So how would that look? All right, I'm going to try and see if I can draw that out here in a way so you can see it. Switch colors. Time to get a different color in here. Okay, let's see. Maybe I'll go with red. Okay, and I might make this even a little bigger here. Okay, so I know that I'm going to be subtracting. Okay, so the circle, the way the circle exists right now, I've got a big circle. On the top, it's got a minus sign, right? And then over here, I've got a smaller circle that has a plus sign, right? Oops. I guess I better make this smaller for sure. There we go, to make it fit. So, and what am I adding? I've got 4 and I've got 5, right? 4 and 5 being added together, and then I've got 10 over here. 10. Okay, so now they're asking me, can I write that as an arithmetic expression? Well, yeah, I know that I'm subtracting 10 at the end, and then what I'm going to do is I'm going to add 4 and 5, right? Now, because of the order of operations, right, I don't actually have to put this in parentheses, but I know, I can, it won't hurt anything. Because order operations, add and subtract are equal. So if I just had it written out 4 plus 5 minus 10, I would still add first and then minus 10. Okay? 10 is going to be taken away from whatever this result is, whatever this evaluates to. Now the words that we use in arithmetic when we learn about addition and subtraction, we call this a sum, right? That's the evaluation of addition. It's sums. This is called a difference, right? The evaluation of subtraction is a difference. And so just want to make sure you're good with your language here. All right, so now they want us to match up these guys. Let's see if I can make these a little bigger. And I think what we're going to do is Well, these, once we zoom in on these, you can't see them very well, and I can't scroll with them either. But we'll have some more that you'll work on in the book here in a little bit. I'll just see if I can have you guys take these first two here, okay, 9 times 4 minus 3, and make your own circles with them. See if you can go ahead and do that. Pause the video. Okay, so I'm going to do this first one. I know that I'm multiplying, so I'm going to be multiplying, right? So that's a multiply, a little asterisk like that for multiply. And I'm going to be multiplying 9, and what am I multiplying it by? Oh, the difference, so I've got to do a subtraction. So the difference between 4 and 3, right? 4 minus 3. So then 4 minus 3 is 1. 9 times 1, this would evaluate to 9. Now notice we got the same three numbers, 9, 4, and 3, only now we've switched where the parentheses goes. So let me get another color for this one. Okay. And see how this would work out differently. That one, this one over here evaluates to 9, right? 4 minus 3 is 1, and then 9 times 1 is 9. What about this one? Well, this one is going to subtract, right, 3 from the product of, so the product means multiply, right? So we're going to be multiplying, oops, that should be a multiply sign, and that's 9 and 4. We got to find the product of 9 and 4 first. So 9 times 4 is 36. 36 take away 3 is 33. So this one evaluates to 33, right? And that one evaluates, let's switch back the color, this one evaluates to 9. So you can see that those parentheses makes a huge difference, right? Everybody's clear on that. All right, now we are going to, I think I'm going to pause the video here just so I can get it uploaded and see that it's going a little bit slow. And then I'm going to start a brand new one for you. So this will be the end of that video.